Hi, in this video I'm going to do the test of passage 3 of the second test of Cambridge IELTS book number 17. Let's get started. First, when we want to start doing this test, we take a look at the first paragraph quickly, just get an idea of what's it about, and then we move on to the questions. Okay, I'm going to read this quickly. Inside or evolution. Two scientists consider the origins of discoveries and other innovative behavior. Scientific discovery is popularly believed to result from the sheer genius of such intellectual stars as naturalist Charles Darwin and theoretical physicist Albert Einstein. Our view of such unique contributions to science often disregards the person's prior experience and the efforts of their lesser-known predecessors. Conventional wisdom also places great weight on insight in promoting breakthrough scientific achievements, as if ideas spontaneously pop into someone's head, fully formed and functional. Let's move on to the questions. Okay, the first question number 27, is about the first paragraph that we just read. It says the purpose of the first paragraph is to defend a particular idea, compare certain beliefs, disprove a widely held view, and outline a common assumption. So let's go back to that again and see that which option would actually be suitable for this one. So it's basically saying that there is this popular belief. It is popularly believed that scientific discovery is actually the result of sheer genius. Like the people who discover something scientifically, they're only geniuses, and the ideas spontaneously, like out of nowhere, popped into their mind. They came up with these ideas without doing any experiments, without any trial and error. So this writer is saying that this is the common belief that is held by a lot of people, and they don't actually pay attention to these people's prior experiences, for example, their failures. So this writer, the only thing this writer is doing in this paragraph is talking about this common belief. So the answer to the question 23 would probably be D. The purpose of the first paragraph is to outline a common assumption. Assumption, it means what people think or what people usually believe. So because of that, the answer to 27 would be D. It's not about C. The writer did not disprove with anything, or did not defend any ideas, did not compare certain beliefs. They just talked about a common belief that a lot of people hold. So because of that, it would be D. Let's move on to question 28. So first we're going to read this question, and then we're going to move on to second paragraph and try to find the answer. It says, what are the writers doing in the second paragraph? Criticizing an opinion, justifying a standpoint, explaining an approach, supporting an argument. Okay, let's see. This would be the second paragraph. There may be some limited truth to this view. However, we believe that it largely misrepresents the real nature of scientific discovery. It's talking about the first paragraph. It's saying that the belief that only geniuses come up with these scientific discoveries and the ideas, they pop into their minds without any effort, it actually misrepresents the real nature of scientific discovery. It means that it doesn't show the real scientific discovery, as well as that of creativity and innovation in many other realms of human endeavor. Okay, let's see. Criticizing an opinion, I think it would be A, because it's saying that this held belief is actually a misrepresentation of scientific discovery. So this writer is criticizing this belief or this opinion in the second paragraph. So it would be A. Compared to other options, this A is more suitable. And 29, in the third paragraph. So let's read this question and then move on to the third paragraph. In the third paragraph, what do the writers suggest about Darwin and Einstein? They represent an exception to a general rule. Their way of working has been misunderstood. They are an ideal which others should aspire to. It means others should try to be like them. Their achievements deserve greater recognition. Okay, let's read third paragraph. This is the paragraph. So it says, setting aside such greats as Darwin and Einstein, means putting them aside, not considering them, whose monumental contributions are duly celebrated, we suggest that innovation is more a process of trial and error, where 2 steps forward may sometimes come with 1 step back, as well as 1 or more steps to the right or left. This evolutionary view of human innovation undermines the notion of creative genius and recognizes the cumulative nature of scientific progress. So this writer here is trying to put them aside. It's like there are exceptions that they need to be put aside, and it says that the scientific discovery is more than that. These people's contribution, they are celebrated, and it says that innovation is actually a process of trial and error. So it's not like these people came up with these ideas spontaneously, or it always works like that only geniuses discover something scientifically. So it says, setting aside such greats as Darwin and Einstein, whose monumental contributions are duly celebrated, we suggest that innovation is more a process of trial and error. Okay? Let's see. They represent an exception to a general rule. Maybe that would be a good answer to that. Let's read the other options. Their way of working has been misunderstood. They are an ideal which others should aspire to. They could be an ideal, but the writer didn't suggest that they should aspire to that. Their achievements deserve great recognition. I don't think so. They already have enough recognition. So probably the answer to question 29 would be A. They represent an exception to general rule because the writer said setting them aside. If we set them aside, scientific discovery is actually about trial and error, not coming up with something spontaneously out of nowhere. Okay. Question 30, John Nicholson. So after reading this question, we have to go back to the passage and look for the word John Nicholson to try to find the answer quickly. John Nicholson is an example of a person whose idea established his reputation as an influential scientist, was only fully understood at a later point in history, laid the foundation for someone else's breakthrough, initially met with skepticism from the scientific community. It means the scientific community didn't approve of his work at first. They held negative opinions about him. Okay, let's search for John Nicholson. It will probably be in the 4th paragraph. Let's see. Yes, John Nicholson is here. Consider one unheralded scientist, John Nicholson, a mathematical physicist working in the 1910s who postulated the existence of proto-elements in outer space. By combining different numbers of weights of these proto-elements atoms, Nicholson could recover the weights of all the elements in then known periodic table. These successes are all more noteworthy given the fact that Nicholson was wrong about the presence of proto-elements. They do not actually exist. Yet, amid his often fanciful theories and wild speculations, Nicholson also proposed a novel theory about the structure of atoms. Niels Bohr, the Nobel Prize-winning father of modern atomic theory, jumped off from this interesting idea to conceive his now famous model of the atom. So basically it's saying that Nicholson came up with some theories, and some of them were false, but then after Nicholson laid the foundation, gave some theories, proposed some theories, there was another person named Niels Bohr, who was the Nobel Prize-winning father of modern atomic theory, jumped off from this interesting idea It means Niels Bohr used the interesting idea of Nicholson to conceive his now famous model of the atom. So it was first Nicholson and then Niels Bohr proposed another theory and jumped off this idea and then proposed a famous model of the atom. So the answer to this question would be C. John Nicholson is an example of a person whose idea laid the foundation for someone else's breakthrough. Who was Niels Bohr, actually used the idea of John Nicholson and then he was able to make a breakthrough in proposing models for atoms. Now let's move on to question 31. What is the key point of interest about the aciducy stirrup placement? So key point of interest, it means what is interesting about this stirrup placement, aciducy stirrup placement. The simple reason why it was invented, the enthusiasm with which it was adopted, the research that went into this development, the cleverness of the person who used it. So we have to see what is actually interesting about this thing named aciducy stirrup placement. Let's search for the word. Probably it will be in paragraph 5 because they're in order. Let's see. I don't see that here. It's actually here, the 6th paragraph, 2nd page. So let's start from the first line to actually see what is going on. Support for this evolutionary view of behavioral innovation comes from many domains. Consider one example of an influential innovation in US horse racing, the so-called aciducy stirrup placement, in which the rider's foot in his left stirrup is placed as much as 25 centimeters lower than the right, is believed to confer important speed advantages when turning on oval tracks. It was developed by a relatively unknown jockey named Jackie Westrop. So this person who developed this idea was unknown. Had Westrop conducted methodical investigations or examined extensive film records in a shrewd plan to outturn his rivals? Had he foreseen the speed advantage that would be conferred by riding aciducy? No. He suffered a leg injury, which left him unable to fully bend his left knee. His modification just happened to coincide with enhanced left-hand turning performance. This led to the rapid and widespread adoption of riding aciducy by many riders, a racing style which continues in today's thoroughbred racing. So it says that this person came up with this idea not because of examining or because of investigation. It's because he suffered a leg injury himself and he was unable to bend, and then they suddenly saw that it could actually enhance the performance of those riders. So because of that, it would be A, the simple reason why it was invented. The simple reason why it was invented was because this person suffered a leg injury, not because they did so many investigations. There was no research here. It was just an idea that someone came up with. Okay, now let's move on to yes/no questions here. Question 32. Acknowledging people such as Plato or Da Vinci as geniuses will help us understand the process by which great minds create new ideas. Let's read it again. Acknowledging people such as Plato or Da Vinci as geniuses will help us understand the process by which great minds create new ideas. So we have to search for these words to answer question 32. It should be somewhere here, Plato and Da Vinci. Okay, here. The notions of insight, creativity, and genius are often invoked, but they remain vague and of doubtful scientific utility. especially when one considers the diverse and enduring contributions of individuals such as Plato, Leonardo da Vinci, Shakespeare, Beethoven, Galileo, Newton, Kepler, Curie, Pasteur, and Edison. These notions merely rebel rather than explain the evolution of human innovation. So it says that these people, studying them or acknowledging their contributions, actually rebel rather than explain the evolution of human innovations. We need another approach, and there is a promising candidate. So they don't explain the human innovations. 32 said, acknowledging people such as Plato or Da Vinci will help us understand the process by which great minds create new ideas, which means innovation, but no, they don't help us understand. So the answer to question 32 would be no. 33. The law of effect was discovered at a time when psychologists were seeking a scientific reason why creativity occurs. So the law of effect, when it was discovered, at a time when psychologists were seeking a scientific reason why creativity occurs. So they were trying to come up with a reason why creativity occurred or existed, and then they discovered law of effect. Let's see if it's correct or not given or false. So here, the law of effect was advanced by psychologist Edward Thorndike in 1898, some 40 years after Charles Darwin published his groundbreaking work on biological evolution on the origin of a species. The simple law holds that organisms tend to repeat successful behaviors and to refrain from performing unsuccessful ones. Just like Darwin's law of natural selection, the law of effect involves an entirely mechanical process of variation and selection without any end objective in sight. So I don't think it necessarily explains creativity. Let's take a look at this again. The law of effect was advanced by psychologists 40 years after Charles Darwin published their groundbreaking work. The simple law was that organisms tend to repeat successful behavior and they refrain from performing unsuccessful ones. It says that the law of effect involves an entirely mechanical process of variation and selection without any end objective in sight. So, of course, the origin of human innovation demands much further study. So the law of effect actually doesn't explain that. And it says it was discovered at a time when psychologists were seeking a scientific reason. They were looking for a reason why creativity occurred. So it doesn't mention when this law was discovered. Here it says the origin of human innovation demands much further study, in particular the provenance of the raw material on which the law of effect operates is not as clearly known as of genetic mutations. So no, it didn't mention. The answer to 33 would be not given. 34. The law of effect states that no planning is involved in the behavior in organisms. Let's see if planning is involved in the behavior of organisms. Was advanced by psychologist Edward Thorndike in 1895, some 40 years after Charles Darwin published his groundbreaking work on biological evolution. On the origin of a species, this simple law holds that organisms tend to repeat successful behavior and they refrain from performing unsuccessful ones. Just like Darwin's law of natural selection, the law of effect involves an entirely mechanical process of variation and selection without any end objective in sight. So there is no end objective for law of effect. The origin of human innovation demands much further study, in particular the provenance of the raw material on which the law of effect operates is not as clearly known as genetic mutations on which the law of natural selection operates. 34 states that no planning is involved in the behavior of organisms. It would be yes, because it said that there is no objective. It's just variation and selection. So the answer to 34 would be yes. It says that the law of effects sets out clear explanation about sources of new ideas and behaviors. It says there is no objective. So the answer to 35 would be false. And 36, many scientists are now turning away from the notion of intelligent design and genius. Many scientists are now turning away from the notion of intelligent design and genius. Let's see. Okay, so it says that, of course, the origin of human innovation demands much further study. In particular, the provenance of the raw material on which law of effect operates is not clearly known, as of genetic mutations on which the law of natural selection operates. The generation of novel ideas and behaviors may not be entirely random, but constrained by prior successes and failures of the current individuals, such as Bohr, and the predecessors, such as Nicholson. The time seems right for abandoning the naive notions of intelligent design and genius, and for scientifically exploring the true origins of creative behavior. So I think that would be able to answer our question. The time seems right for abandoning the naive notions of intelligent design and genius and scientifically exploring the true origins of creative behavior. So it says that now is actually time to scientifically explore the origins, the real true origins of creative behavior. 36 says many scientists are now turning away from the notion of intelligent design and genius. It doesn't say that scientists are turning away from that. It says that the time seems right for that. It didn't directly tell us that scientists are doing that. So because of that, the answer to question 36 would be not given as well. Now let's move on to this part. We have to choose from these options. The origins of creative behavior. The traditional view of scientific discovery is that breakthroughs happen when a single great mind has sudden, so it was in the first paragraph. It says that scientific discovery is popularly believed to result from the sheer genius of such intellectual stars as naturalist Charles Darwin and theoretical physicist Albert Einstein. Our view of such unique contributions to science often disregards the person's prior experience and the efforts of their lesser-known predecessors. Conventional wisdom also places great weight on the insight in promoting breakthrough scientific achievements, as if ideas spontaneously pop into someone's head, fully formed and functional. So it says the traditional view of scientific discovery is that breakthroughs happen when a single mind has sudden invention, sudden goals, sudden compromise, sudden mistakes, luck, inspiration, experiment. It would be inspiration. It's a lot of people might think that, okay, they suddenly come up with these ideas. The ideas spontaneously pop into their minds, or they're suddenly inspired by something and they propose theories. So because of that, they think that one single mind has sudden inspiration. The answer to that would be F. Although this can occur or happen, it is not often the case. Advances are more likely to be the result of a longer process. In some cases, the process involves, such as Nicholson's theory about proto-elements. Let's see what the process involves. What did the Nicholson's theory involve? Let's see where Nicholson was. Here. A mathematical physicist working in the 1910s postulated the existence of proto-elements in outer space by combining different numbers of weights. Nicholson could recover the weights of all the elements in the then known periodic table. These successes are all more noteworthy given the fact that Nicholson was wrong about the presence of proto-elements. They do not actually exist. Amid his fanciful theories and wild speculations, also proposed a novel theory about the structure of atoms. So it was actually a wrong idea. It was a fanciful theory. It was just a wild speculation that Nicholson gave. Let's see which option would fit. Involves invention, goals, compromise. I think it would be mistakes. It involves, in some cases, this process involves mistakes, like Nicholson, who actually made a mistake and proposed some false theories, fanciful theories. Nicholson's theory about proto-38 would be D. Fanciful theories about proto-elements in others, simply necessity may provoke innovation, as with Westrope's decision to modify the position of his writing stirrups. There is also an element of, for example, the coincidence of ideas that led to the invention of post-it note. So let's see, element of something that led to the invention of post-it note. Let's see which paragraph it was in. Post-it note. Maybe it would be here. Plenty of other stories show that fresh advances can arise from error, misadventure, and also pure serendipity, a happy accident. For example, in the early 1970s, two employees of the company 3M each had a problem. So they had a problem at the same time. It was like a coincidence. Spencer Silver had a product, a glue which was only slightly sticky and no use for it, while his colleague Art Fry was trying to figure out how to affix temporary bookmarks in his hymn book without damaging its pages. The solution to both these problems was the invention of the brilliantly simple yet phenomenally successful post-it note. Such examples give lie to the claim that ingenious designing minds are responsible for human creativity and invention. So sometimes genius minds are not responsible for that. Far more banal and mechanical forces may be at work. Sometimes just mechanical forces. Forces that are fundamentally connected to the laws of science. Okay. There's also often an element of, it would probably be luck, element of luck. For example, the coincidence of ideas that led to the invention of the post-it note. Yeah, it was just luck. Like there were two co-workers that were having a problem and then suddenly they came up with this idea. They weren't necessarily geniuses. So sometimes it's just luck. That's why creativity happens or an invention happens. There may be no clear something involved, but merely a process of variation and selection. Okay, it was somewhere here. Involves an entirely mechanical process of variation and selection without any end objective insight. Objective means goal. So it would be, there may be no clear goals involved, but merely a process of variation and selection. And that is the end of this passage.